Right, this is week 3. In this week, we will talk about relational algebra and calculus. So first, we need to know there's two definitions we talk about in this chapter, which is procedural language and the non-procedural language. So the definition for the procedural language, basically, this language allows the user to tell the system what data is needed and to tell the system how to retrieve it. Okay, so this basically the example would be a relational algebra. Okay, so the user will tell the system the sequence of the operations, like what to do, what kind of data we need, and how you retrieve it. It's exactly like we tell some people to do something for you. You explain, what kind of things you want the people to do and how to do this. For example, you ask people to grab something for you. You will describe, these things it is in order to, that people can find the things. At the same time, you need to tell people how to grab this. You need to take the bus, you need to take a train, you need to walk, you need to, there's several directions you need to go. This is a procedural language. Okay, so what's the non-procedural language? So non-procedural language allows the user to state what data is needed, but they do not need to specify how to retrieve it. So the example would be relational calculus. So user only defined the condition. System need to figure out how to process. Okay, so it's like, I need this one, I need this, I need a bottle. Okay, you only describe what kind of the depth. So I need this bottle, I need you to grab for me, but I don't tell you how you can grab. I probably just tell you, okay, I need you grab this bottle in 1 second. So how you retrieve it is depending on you. You need to figure out, what kind of the approach you can grab that bottle in 1 second. So this is something system need to figure out. So closure of the relational operations. So basically, you need to work on one or more relations. It's kind of like you need, based on those relations, you need to produce a new relations. We do not change any original relations. It's like you create a table. This table, for example, students information table, but at the same time, you want to grab the only student ID, from this table. So you will create a new table, and this table only includes student's ID. So this is the closure of the relational operations. Okay, so there are many different types of operations which can be used for relational algebra. Okay, so we will talk about some of the examples and give you guys some sense of the operations. So there are common type of the operations, which include selection, projection, product, union, sets difference. Okay, so there are many different types you need to understand. So we have 2 types totally. One is unary, another is a binary. So for the selection, so basically you're trying to, based on one table, you try to fill the table based on specific condition. Okay, so I have some example later. We have a projection. You specify the specific column, then creates new relation. You combine, so this product, you trying to combine the the all rows or record from two tables. Union, you combine rows from two relations, remove all duplicate. Sets different, basically you try to retain the rows in the first relation but not in the second relation. Okay, so first example is a selection. Okay, so selection is a unary operator that will create the value for all rows found in the table that satisfy a given condition. Okay, so we need to make sure you understand what the condition means. Right here, this is an example. So we have our original table. In this table, we're trying to create something new. So right here, or is a condition. You select all of them, so you create a new table which include all the information from the original table. If you put another conditions right here, you say all the price less than $2. Okay, so you need to try to find the selection, the condition is the price. Then you try to compare each of the price which is less than 2, then you can put them into a new table. Okay, so this is a new table. So, and the price will be less than $2. Or we want to find the record which is P code number is 311452. So they will check the P code is right here, one by one, then find out this exactly the code number and make them into a new table. So for this one, you can tell the attributes, they don't change. We only select the record or the rows which satisfy with the condition you provide. Okay, so you can do this example by yourself. This is how you note based on the formula. Okay, select condition with table name. Project operator. So project operator, they will create all value for the selected attribute. So that means they only produce the records based on the selected attribute. Okay, that means this table have so many different attributes, but we only display the certain attributes and create a new table. Okay, this is the way how we write. We put the attribute name. We're using the pi as a symbol to say this is a project. Then you can return the specific column but include all the rows. So this is one example. So you can see here, this is exactly the original table. However, we want this table only display with price only. Okay, so right here is new table. In this new table, only display the price. Okay, or you can try with the script and the price, and this table will create only the script and the price. We have a P code and the price. This will produce only the P code and the price table. Union. So union will combine all the rows from two tables. Okay, and remove all the duplicate. This table must be union compatible. Okay, compatible. Compatible, that means you have the same structure. Okay, the same structure, that means this table have to have same number of the column. Each column, the attributes, they should have the same domain. So for example, one column is for number only, and the first column should be number. Then another table, the first column is for the string. So they are not domain compatible. So that means it's not the union compatible. So if you want to combine the two tables, you need to make sure they are union compatible, the same column, and each column should be matched with same domain. This is how we write down. Okay, so this is an example. We're trying to combine these two tables. So you need to see this is the first column. You will see, okay, it's they do have the same number of the column. 1, 2, 3, 1, 2, 3, right? Second, they need make sure the domain is the same. The first column is number, the first column is number. The second column is string, the second column is string. The third column is price, which is the currency format with only 2 floating points. Keep only 2 floating point digit. Okay, so it's the same thing. That means they are compatible. Okay, compatible. Then you can just combine them together, produce new table. So one thing right here, you need to make sure they will remove the duplicate column rows. So that means, for example, if right here we have something is 1, 2, 3, 4, 5, 6, which is the same as this one. If you combine them together, this line will delete it. They produce this unique table. Okay, product, the operator, basically they combine all the possible pair of the row from the two tables. Okay, so for example, this two table, what they trying to do is this, the first one, this based on the order, table 1 times table 2. So right here, table 1, table 2. They trying to do is this table 1 times with table 2. Each row, they will time every row of the the table 2. So that means in this, the first row, they will combine them together with 3 of the record of the table 2. So which creates this table. Okay, so the second row, they will do the same thing. They combine them together. They create another 3 record. So how many records for each record of the table 1? It depends on how many of them they need times from the table 2. So for this one, they have 3. So each row, they will times 3. Okay, so right here, 3, 3. They combine them together. You have a total table right here. Okay, so just to make sure, each row will times with every row of the table 2. Okay, that's how you create a new relations with a product operator. Difference operator. So basically, they trying to create all the rows in one table that is not be found in another table. So table 1, table 2. So if table 1 minus table 2, okay, we're trying to find the difference. You know, the table 1 has but the table 2 doesn't have. Okay, so for this one, table 1 is right here, table 2 is right here. We're trying to find the difference. So they will see right here, George Jones, do they have a difference right here? Yes, so this is unique. They will put down over here. Jane Smith, can they find Jane Smith right here? No, so then we can find here. Peter Robinson, do we have Peter Robinson? No, so we put it over here. Franklin Johnson, do we have Franklin Johnson? We check 1, 2, 3. This is Franklin Johnson. So that means they are not unique. So it's not into this table. Then we check the Martin Lopez. So Martin Lopez is right here, no, right here, no, right here, no, right here, no. That means this is unique. Then we put them into the table and create a unique table combined by these two. Okay, so this is for the week 3. Make sure you go check all the quizzes and make sure if you have any question, just let me know.